For this activity, we're going to use a thermistor and an Arduino to measure temperature. You'll need an Arduino Uno, a USB cable, a 10 kilo ohm resistor, a thermistor, and some jumper wires. For a 4-band resistor, look for a brown, black, and orange band in that order. And for a 5-band resistor, look for a brown, black, and red band in that order. A physical parameter such as temperature, how bright it is outside, or the moisture of the soil needs to be converted to something that the Arduino can measure. Arduinos are actually capable of measuring voltages of up to 5 volts. We're going to take advantage of this capability to measure the ambient temperature of the air. But first, we'll need to learn some background information and some terminology. A transducer is a device or component that converts a physical quantity such as temperature into something that the Arduino can measure. With the help of a voltage source, a thermistor converts temperature into a voltage that we will measure with the Arduino. When you put two resistors in series and connect them to a voltage source, you create what's called a voltage divider circuit. For the purposes of this class, two resistors in series means that the leg of one resistor is connected to the leg of another resistor. In the voltage divider circuits that will be built for this class, the voltage is divided between the two resistors. The voltage across one resistor is proportional to its resistance divided by the sum of both resistances. For example, for this voltage divider circuit, 5 volts is connected to the two resistors in series. Since the two resistors have equal resistances, the voltage is divided equally between them. R1 has 2.5 volts across it, and R2 also has 2.5 volts across it. The general equation for the voltage across the resistor designated as R2 is shown here. For a voltage divider where 5 volts is connected to a 100 ohm resistor and a 400 ohm resistor, the voltage across the 400 ohm resistor is 4 volts. The Arduino Uno has a set of pins dedicated to measuring voltage. They're called analog input pins. There are 6 of them, and they are designated as pins A0 through A5. In the schematic below, to measure the voltage across resistor 2, you would connect an Arduino analog input pin to the circuit as shown. A thermistor is a special kind of resistor. The resistance of the thermistor changes with temperature. There are many different kinds of thermistors with different characteristics and different packaging. The one we will be using for this class looks like this. The general circuit for using a thermistor is shown below. There are a few different electrical schematic representations for a thermistor. For this class, we will use the schematic symbol shown here. Notice that the circuit is essentially the same as the voltage divider circuit. The only difference is that we replaced one of the resistors with a thermistor. Typically, the documentation for the thermistor will tell you how to use it and what resistor to use with it. For this activity, a 10 kilo ohm resistor will be used with a thermistor. Here's how the final circuit should look when you put everything together. Let's build it. Insert one leg of the 10 kilo ohm resistor into F5 and the other end into F9. Insert one leg of the thermistor into G9 and the other leg into G12. Insert one end of a jumper wire into the 5-volt pin of the Arduino and the other end into J5. Insert one end of another jumper wire into the ground pin of the Arduino and the other end into J12. And finally, insert one end of another jumper wire into pin A0 of the Arduino and the other end into J9. Insert the USB cable into the Arduino. Then insert the USB cable into the Chromebook. Now let's type the code in. Open the Arduino web editor, click on New Sketch, change the file name to measure_temperature, and then type the code as shown in your class booklet. Click on Verify and Save, then Upload and Save. Click on Monitor. After that, you should start seeing temperature measurements from the Arduino. Now, try squeezing the thermistor between your fingers to heat it up. Look at the messages in your Arduino web editor to verify that the Arduino sees the temperature increase. Let's take a closer look at the code and understand what's going on. Like in the previous sketches, everything between a /* and / is ignored. We took advantage of this and we made a comment about what the sketch is supposed to do. Let's ignore the line of code in line 5 for now. We'll get back to that. Everything in the setup section is performed only once, and everything in the loop section is performed over and over again. The code in line 5 creates a variable called temperature that will be used in the rest of the code to perform calculations. You can think of a variable as a container that stores information. For our purposes, the variable called temperature will store a value for the temperature that's calculated based on the voltage across a thermistor and an equation that's been calibrated to provide the temperature in degrees Celsius. The serial begin command here is identical to the one used in the previous example. It tells the Arduino to prepare to use serial communication with a baud rate of 9600 baud. The analog read command takes a voltage measurement at the analog pin that is specified. In this case, the thermistor is connected to analog pin A0, so we put a 0 for the analog pin number. Let's get into how the Arduino measures voltage. When an Arduino measures voltage using the analog read command, it doesn't give you a value between 0 and 5 volts. Due to the nature of the numbering system used in computers, it gives you a number between 0 and 1023 that is proportional to the voltage measured. Don't worry about this too much, it's just a simple proportion. A voltage measurement of 5 volts corresponds to a value of 1023, and a voltage of 0 volts corresponds to a value of 0. Everything in between is just a simple proportion. You simply multiply the actual voltage to 1023 over 5. The equation in line 14 takes the number that the analog read command gets, that would be a value between 0 and 1023, and it calculates a temperature in degrees Celsius according to the equation. This calculated value is then stored in the temperature variable where it will be used later on in the sketch. Determining this equation requires quite a bit of explanation, but we'll leave the explanation for you to read about in the class booklet. The serial print command is very similar to the serial print line command that was used in the previous activity. However, the serial print line command includes what's called a carriage return. That means that the next message that's sent appears on the next line in the Chromebook, but we want the next message to appear next to the temperature message, so we use the serial print command instead. The serial print line command can not only send predefined messages like when the Arduino said hello in the previous activity, but it can also send the contents of a variable to the Chromebook. In this case, the Arduino has been programmed to send the temperature measurement in degrees Celsius to the Chromebook in decimal format. Don't worry about the format too much. For this class, everything will be sent in decimal format. And finally, the delay command causes the Arduino to pause for 1 second. After that, it reaches the end of the loop section and it returns to the beginning of the loop section in line 14. So the end result should be that the Arduino takes a temperature measurement and sends it to the Chromebook every second. Now try programming the Arduino and verifying that it sends you the temperature measurement.